Okay, let's discuss the governance DAO that Dynamo has set up to manage their Dynamo 4626 contract. So we had a few goals that we wanted to achieve. We didn't want someone to have to vote every time a strategy was proposed for the vault, but at the same time we wanted to prevent denial of service attacks because we're trying to crowdsource these strategies. So hopefully there's people who are looking to see what the various adapters that we're connected to, how they're behaving, and when they see that one adapter is improved over the other, they can then present to the contract directly their own idea for a strategy. And if there's no objection to that strategy within 6 hours, then it's assumed that the strategy is a good one, and they can then call the contract and cause it to be activated and be the new active strategy. There's an incentive of 1% of the fees that are earned go to whoever was the person who submitted the strategy that was active at that time. So there's a financial incentive to submit a strategy and for your strategy to be selected. In addition, we suspect that most strategy submitters will also be investors into the vault. So how do we make this thing work? So we have a formal definition of the contract structure and behavior here, and we talk about how to propose a strategy, all the definitions of the parts that are involved, and we have a sequence diagram for every major function in the governance contract. So here is for submitting a strategy in detail. You can change your mind and withdraw a strategy. You think it's not the one that you want. If you're the original proposer, you can withdraw the strategy. And then then we have a list of governors or guards. Actually, these are people who can vote for or against a strategy and keep an eye on it. So presumably, there's going to be bots with an indexer that's looking to see that a new strategy has been proposed. So that event shows up, it would highlight to the people who care about this that, okay, here's the structure of the strategy, and as long as there's nothing unusual or out of bounds by it, anything looks wrong, then everyone can just ignore it. But if they see that that doesn't look like a good strategy to me, they can go review it, and they can elect to reject the strategy, and so they can vote to do that. Or you can vote to endorse the strategy. Now, there's no need to vote to endorse a strategy because it'll automatically be allowed to be activated after the delay time. However, if there is a rush to get a new strategy in place, as long as a majority of the guards actually vote to endorse it, then they can short circuit the time delay and that strategy can be activated right away. Activating a strategy, once a strategy is eligible for activation, there is a short period of time after that 6 hours where no other strategy can be proposed to replace the new one. And so this gives time for somebody to actually call the function to activate the strategy itself. Activating the strategy does not actually cause funds to be rebalanced in the Dynamo 4626 contract. That only happens when a separate function to rebalance or money is moved in or out of the contract. We have a separate video describing the Dynamo 4626 contract that demonstrates this. So you can activate the proposed strategy, and then we can also manage the number of guards that can vote on something, and we can also vote to replace this governance contract with some other contract that might, if we change our mind about how we want to govern the system, this governance contract can vote to replace itself. So that's the high-level structure. We have the source code here for the governance contract. It's written in Viper, and it's like 570 lines, thereabouts. Yep, of fairly well-written, documented Viper code that has all been extensively unit tested. So our unit tests for governance is about 13-20 lines of Python code. We use Ape as our test running tool. And everything is actually running and hitting against a snapshot of the Ethereum mainnet. So when we're actually interacting with various contracts and stuff, we're hitting the real code that's actually deployed on mainnet. So let's see. Is there anything that we want to talk about here? Some things that are fixed is the maximum number of guards there can be, the number of pools that this governance contract can manage. So we can actually manage multiple vaults, and each vault can have its own strategy. And there is another value, the default minimum proposer payout, that deals with if fees that have been earned are lower than gas costs, for example, they won't automatically be paid out, so we won't waste gas. So there's little optimizations like that. Lots of stuff going on. Let's go ahead and look at a demo. So let's run this thing. So this is going to deploy a governance contract. And here we have a fresh governance contract talking to a 4626 Dynamo 4626 contract. So it's got a vault already that's going to manage. There is no strategy active right now, so these are all default empty values. And so what we're going to simulate here is somebody calling the submit strategy function. So that gets done, and it has a timestamp for when it was submitted. And what happens is, as it's now a pending strategy, we take a snapshot at the time it was submitted for how many guards there were at that time. And so that will be the basis of what the voting will be. If during the time the strategy is still pending, a number of guards are added or removed, it will not change the guard count that's necessary in order to handle the votes. So the person just submitted the strategy, it is pending, and the same person immediately afterwards is going to make a call to request to activate the strategy. Well, this gets rejected because the time delay for waiting till a strategy can be activated has not happened. In this case, it's a 6-hour delay. So what we're going to do here is we're going to simulate the passage of time and call the activate strategy. And so now that was successful. So we can see here that nonce number 1, the pending strategy, is now the current strategy. All those it has been activated at this time. We can see that 6 hours and 1 minute, almost 2 minutes after after it was proposed. You see, withdrawn was false. Nobody voted. The proposer never tried to withdraw it, and there was no votes necessary in order to do this. So this is, again, the presumption is that everyone's acting in the best interest of the contract most of the time. So there's not a need for people to vote on things unless there's an exception. So let's submit yet another strategy. And now we're going to say that, okay, this is a strategy that somebody does, something's not right about it. It's moving funds into a LP that is not an LP that's performing well compared to what's going. So, we want to reject this one. So one of the guards votes to reject it. So now there's here this one vote to reject. And now we're going to, let's say that nobody else votes on it at all. We let the time pass, and we try to activate the strategy. That's going to fail, because you can't activate a pending strategy if the votes to endorse are less than the votes to reject. So basically, this strategy was vetoed by one of the guards, and nobody else felt the need to step in and change that decision. So this strategy did not make it. So that was nonce number 2. So we're going to submit yet a new strategy. This is nonce number 3. And in this case, there's some contention about whether this should be the strategy or not. So we've got 2 people voted to endorse the strategy, 1 person voted to reject the strategy. We let the 6 hours pass. Nobody stepped in to change anything, and so that was actually able to be activated. And so now that is passed by acclamation. That is the new active strategy. So we're going to do another one, and we'll do another vote here. So this is nonce number 4, and in this case, we had 3 votes to endorse it right away. So this maybe is an emergency strategy, and since the number of guards was 5, this is a guaranteed majority, and we do not have to wait for time to pass. So you'll notice the last one, it took 6 hours before it was activated. This one, boom, 1 minute later, the strategy was able to be activated because we had this majority of guards voting positive, and it could not be rejected. So that's how you short circuit making decisions and dealing with time delays. And that's the basic functionality of the governance contract. There's a lot of other little subtleties and stuff, but I think this gives a good idea of how it works.